This problem has actually been a problem for the entire month of May, so I'm sure those of you who have looked at the problem already know the rules. And if you're trying to make a 10-digit number and you have to use all 10 digits, you may know already that if you're trying to arrange 10 things, there's 10 factorial different ways to do it, or 3,628,800. So those of you who are going to use trial and error to do this problem, well, good luck with that. But you also know, most of you, that a number has to end in 0 to be divisible by 10, and a number has to end in either 5 or 0 to be divisible by 5, and we've already used the 0. So we've got those two digits placed. There's only 8 digits left, and 8 factorial is a mere 40,320 for you trial and error people. Still quite a few, so let's see what else we can do to narrow this down. Well, even numbers only go into other even numbers, so the second, fourth, sixth, and eighth slot must use up the remaining 4 even digits, leaving the remaining 4 odd digits for the first, third, seventh, and ninth slots. Then we're using the divisibility test for 4, which says that if the final 2 digits of any number form a 2-digit number which is divisible by 4, the entire number will be divisible by 4. So we can cross the 4 and the 8 out using that test. The divisibility test for 6 is related to the divisibility test for 3, allowing me to cross the 2 and the 6 out here. If a number is even and the digits add up to a number divisible by 3, then the entire number is divisible by 6. And since the first 3 digits must be divisible by 3, those 3 digits must add up to a number divisible by 3. So the middle 3 digits also need to add up to a number divisible by 3. And that's how I applied the test here. The next 2 that I crossed out had to do with the divisibility test for 8. If a long number ends with 3 digits that form a 3-digit number divisible by 8, the entire number will be divisible by 8. So applying that test, I can knock out the 4 and the 8. And since the 2 and the 6 must be used in the 4 and the 8 slots, they can't be used anywhere else, so I can cross the 2 and the 6 off of the second slot. Now, looking at the first 3 slots and using each digit only once, here's the only 8 combinations that form 3-digit numbers which are divisible by 3. And then looking at the second 3 digits, there's only 2 of the remaining digits that form 3-digit numbers divisible by 3. And when we combine those are the 8 possible numbers divisible by 6. And then we take the 4 odd digits left, make sure we don't repeat a digit, and there's 12 possible things left for numbers divisible by 7. And then we grab a calculator and try all 12. That doesn't take that long. It's a lot less than 40,000. And those 2 numbers are both divisible by 7, and each digit is only used once. Well, we then realize that without repeating a digit, only the 6 can go on the top one and the 2 on the bottom one. We use our calculator, divide by 8, the top one fails, the bottom one works. There's only 1 digit left for divisibility by 9, and it works, and you can either try it on a calculator or you can apply the test that if they add up to a number divisible by 9, it'll work, and they all add up to 45, so it works. The 0 is left for the 10-digit number 3,816,547,290, the answer to this week's or this month's problem. And there's the test for those of you skeptics out there to demonstrate that it does meet all the rules of the problem. Each digit is only used once. And here is the math department of the Latin School of Chicago, which says, have a great summer. See you next fall for more middle school problems of the week.